Alright, welcome to my last video on Exam 3 Essay 1. In this video I'm going to cover the cardiac cycle. There's lots of elements to the cardiac cycle. Specifically I'm going to cover how the pressure of the aorta, the ventricle, and the atrium are always constantly changing. I'm going to talk about the volume, specifically the volume of the blood in each segment of the heart, and I'm also going to go over several other elements such as the EKG, the sounds, and several other stuff. So to begin, I'm going to draw a graph and a key. So imagine this very long graph. And the key, so I have this black marker. We are going to use black to represent our aortic pressure. So each color is going to represent a pressure in this case. Blue is going to represent ventricular pressure. And last but not least, red is going to represent our atrial pressure. So to begin, I am going to begin with our aortic pressure. So that one's pretty straightforward. So if we imagine pressure, I'm going to divide this into segments. So this whole section right here is going to indicate our pressure of each area of the heart. So our aortic pressure is going to happen at around 120, and our units are going to be millimeters of mercury. So we've got our line here. It's just kind of going to be straight, and then it's going to go down a little, and then go up a little bit, and then come down like this. I will describe that in just a moment. And then it's going to return to its normal state. And then our atrial pressure is going to be down here at around 80 millimeters of mercury. And the reason I say 120 and 80 is because that is our range of our normal blood pressure. So our high should be around 120 and our low should be around 80. And that's representing systole and diastole, which I will explain in just a moment. So back to our atrial pressure, we're going to have a line. It's going to kind of come up like this, and then it's going to kind of go forward. There's going to be some bumps here and there, and then it's just going to kind of stay constant throughout the whole process. The ventricular pressure is going to be the most interesting though, because in a heartbeat, that's what will cause the blood to flow out to the entire system of the body. So our ventricular pressure, it's going to start below our atrial pressure. It's going to come up like this, and then eventually it's going to cross a point in the atrial pressure and come up towards our aortic pressure, and it's going to at some point get higher than the aortic pressure and then come back down, and then once again cross. Actually, let me draw that better. So it's going to come up, and then it's going to cross our aortic pressure again. It's going to come down to this point that I mentioned earlier, and then it'll come back down. It's going to cross our atrial pressure again, and then it's just going to stay below until it hits the next beat. So I'm going to go ahead and explain what just happened here. If I divide this whole system in segments, I'm going to describe that this left side right here is going to be a part of our diastole, which is where the left ventricle is relaxed. I also failed to mention this is describing the left ventricle of the heart. So focus on the left ventricle. This is diastole, where it's relaxed. But then when the ventricular pressure is like greatly increased, that's going to be called our systole, and that's where we get our heartbeat. So our heart's going to contract, which is going to pump blood all the way out to the rest of the body, and then eventually it's going to come back down and be relaxed and be at a lower pressure than the atrium and everything else. So I will describe what happens to all the different valves that are involved in the left ventricle. So the first thing that's going to happen is in the heart, which let me come over and draw this to give you some context. So we have our heart. So focus on this section right here, which is our left ventricle. So in our left ventricle, we're going to have two elements. We're going to have our bicuspid valve or our mitral valve. That's going to allow blood to flow from the left atrium to the left ventricle. We also have something called our semilunar valve, which is going to allow blood to flow from the left ventricle all the way to our aorta, which is going to be this giant artery right here that will cause blood to flow to the rest of the body. So when the heart is relaxed, it is going to allow blood to flow into the ventricle, which is going to allow our mitral valve to be open. But then as soon as it hits this point where it crosses the mitral pressure or the atrial pressure, that is going to close, because it is going to start its contraction. When this valve right here closes, so I'm gonna draw it closed, all that blood is going to be in the ventricle, and now this guy is going to be open, so it's going to pump blood through the semilunar valve into the aorta, and that whole muscle of the left ventricle is going to be contracted. So now, if we go back to our chart, it will come up here all the way to aortic pressure, and when that happens, between the closing of the mitral valve and this point, which is going to be our semilunar valve, which I'll abbreviate as SL, is going to open. We are going to call that isovolumetric contraction. I don't have any room to write that up, but isovolumetric contraction, meaning the volumes of the left ventricle and the left atrium are going to be the same, but only for a very brief moment. After it hits this point where the semilunar valve opens, it is going to be greater than the aortic pressure, and so that's what causes our blood to pump through the aorta and then come back down, and it's going to hit this part right here called the dicrotic notch. And this part's very important because that's when our semilunar valve closes, and then it will come back down and our mitral valve will open back up, and that's when the heart is going to relax. So I'll let you visualize this again. So our semilunar valve is shut. That means blood can no longer flow through the semilunar valve to the rest of the body. And then our mitral valve is now open. That's going to allow blood to flow through to the ventricle, and that's what's going to introduce our diastole. And once again, between the points of the semilunar valve closing and the mitral valve opening, that is going to be isovolumetric relaxation. So that's when, once again, this volume is going to be the same on either side, but only for a very, very brief moment. The next thing I want to go over is volume change. So I'm going to represent this with a black marker. So our volume change is going to say from 120 milliliters down to 50 milliliters. And I'll explain those numbers in just a moment. So basically, at the very beginning, we are going to start off by staying at 50. It is going to gradually increase in volume because our ventricle is gradually increasing in volume as the mitral valve allows blood flow to be in. Let me draw that a little bit better. So our mitral valve is going to allow blood flow to enter, and then as soon as it hits that point where the mitral valve will close, it's going to be, actually, let me draw that line. Okay, so this is our 120. So like I said before, isovolumetric contraction is where our volume is going to be the same. And then as soon as it hits the point where the SL or the semilunar valve is going to open, it's going to gradually and dramatically drop down because all that blood is going to flow from the ventricle to the aorta. And then we are going to hit our next, point, which is our isovolumetric relaxation. Once again, the volume is going to be steady, and then it will gradually decrease until it hits the next beat. And the 120 and 50 difference, we call that our stroke volume. And that's the amount of blood that the ventricle can carry at a time, is our stroke volume, which is going to eventually affect cardiac output, which I will discuss in a different video next time. The second thing I want to go over is the EKG and how it is read in terms of what is happening in this cardiac cycle here. So I'm going to draw these lines a little bit further down to give more clarity on what's happening. So this is going to be our dicrotic notch line. So what's happening now is we have our P wave, and then we're going to have our QRS. So our R wave is going to hit here where the semilunar valve opens, and then our S wave, which is going to happen right before the maximum ventricular pressure happens. So we've got our QRS, and then it's going to happen, and then our T wave is going to happen as soon as the SL or semilunar valve closes. So we got our P wave here, Q wave here, R wave here, S wave, and then T wave. And that's a very long EKG, but that is essentially what happens in the cardiac cycle. Then the last thing I want to go over is sounds. So as we know, the heart sounds are going to be lub dub, and that's going to happen up here. So when I start that, it's going to begin the sound when the mitral valve closes. I will label it like this, and then that's going to be our first sound, lub. That's when the heart will contract, and then we will hear our dub sound when the semilunar valve closes, and that's going to be our dub when the heart relaxes. And this happens very fast, as you know, in a heartbeat. That is pretty much it for the cardiac cycle. I hope you enjoy my next video coming up.